I'm going to talk to you today about another floor equation. Now, this particular floor equation just involves two floor functions. And I want to talk about a way to look at floor functions that'll help us as far as determining a solution to this particular equation. Now, let me just start out. So let's say we have the floor of any expression. I'm intentionally using a different symbol here. I don't want to use x. Okay, it's like we overload x, right? So the floor of x is equal to, it's always going to be equal to some integer. For the sake of being concrete, I'm just going to use 5, okay? That is a property of the floor function. It always maps any input to an integer. Now, this means you can actually do if and only if you want to on this. Actually has this meaning. It means that question mark, for you to have a floor of 5, expression number or whatever you want to be, you have to be a proud member of this closed open set from 5 inclusive to 6 not inclusive. Okay, because the floor of 6 would be 6, right? So this closed open is huge right here. You can't just ignore it. Closed 5, the floor of 5 is 5. The floor of 6 is 6. That's why it's not included. Now, again, let's say our question mark was equal to 5.8. All right. Okay, well, that means that 5.8 has to have a floor of 0.8. All right, so we can write that down. That means that the floor of 5.8 is 5. Let me just write that over here. See, it's kind of a way of thinking about it without even having to interpret that. Okay, so that says 5.8, the floor of 5.8 is equal to 5, right? So you see, this floor function, it actually induces an interval. Okay, it actually creates an interval of numbers. Only numbers in this closed open interval are going to have a floor of 5. 5 would be included, 5.2 would be included, 5.999 would be included. Okay, that interpretation of the floor function actually comes in quite handy as far as what we're going to be doing right here. Now, okay, also what I did right here is I undressed the floor function. I just took away the floor operators and I just looked at it from the standpoint of a linear equation. And you can see pretty quickly that 10/3 is a solution to this unfloored expression. Now, the reason why you can look at this to get a great estimate is because the floor function never returns an output more than 1 away from the input, right? So it's very legitimate to just look at the corresponding expression that you get, the equation that you get without the floor notation, okay? And again, you can verify right here that 10/3, the floor of 10/3 plus 1 is 4, okay? The floor of 2 times 10/3 plus 2 is 8. And so we almost got a solution, you see, but it came out equal to 12, right? Came out equal to 12. So 10/3 is not a solution to the floor equation, but it is a solution to this original equation, right? Now, so that leads us to go, well, let's think of a number bigger than 10/3. Well, I chose 7/2, right? Because 7/2, the arithmetic works out very nicely, okay? And you'll notice that the floor of 7/2 plus 1 plus the floor of 2 times 7/2 plus 2 gives you 4 plus 9, which is 13, which means that 7/2 is a solution. And you'll note that anything less than 7/2 would have had a floor of 12, right? So 7/2 is going to be the smallest solution. Now, it's tempting to stop out here, but this definition of the floor function creating an interval suggests that there's going to be an interval of solutions, okay? So again, our floor levels are 4 and 9, and that's what we're going to use on the next page here, okay? So let me move along here. And again, y'all keep this in mind. I can refer back to this page, but 4 and 9 are the floor levels we'll be using individually for this expression to see if there's more to the solution than just 7/2. Okay, let's go ahead. Let's clear this out, and we'll move along to the next page. And again, y'all do remember that 4 and 9 are the floor levels we're interested in. We're looking to see what the interval is. We suspect an interval is going to be a solution rather than just a single number. Okay. Now notice right here, this is a little lemma. Let me. Now remember, our floor levels from the previous was 4 right here and 9 right here, right? Now this may look like a mess to you, but this is exactly what we did earlier. It's just that our question mark is equal to x+1, right? So that would mean that x+1 would be trapped between m and m+1. And if you do the algebra on this, you get that x would have to be between m-1 and m. And in a similar fashion, for 2x+2, you would get that x would have to be in this interval right here. Okay. Now let's note what happens right here fairly quickly. If you put 4 in right here, we get that x has to be in the interval closed 3, open 4, right? Okay. Now 7/2 is definitely contained in that interval, right? Okay. Now right here for 9, which we solved this on the previous page. If you put 9 right here, you're going to get what we learned was part of the solution set earlier. Okay. And then if you substitute 9 right here, 9 minus 1 is 8 over 2 is 4. And so you can see, folks, that the solution set has to be where these two sets overlap. That is the overall solution set. The overall solution set is going to be 3 over 4. Excuse me, 3 comma 4. And we're going to intersect that with this set 7/2 4. Okay. And of course, these two sets overlap, 7/2 being a bigger number than 3. The intersection of these two sets is closed 7/2. It's containment, really, right? So you have 7 closed 7/2, open 4 as the solution to the original equation. Now, I don't have the original equation on the screen as Luck would have it, but let's keep this in our memory bank. So now go back. This says closed 7/2, open 4. Okay, is the solution range, the solution interval for the entire system. So let's back up to the next page, keeping this in mind here. So again, closed 7/2, open 4. Okay, and let's back up to the original. Okay, now again, y'all, I would like to keep this all on one page, but it's not so easy. But so remember, we just showed that, or we trying to convince you that this is the solution interval, right? Now, again, if you substitute in here, notice that when you substitute 4 into the expression, let's see here. Let me get this. This thing's actually in my way right now. Can I move that out of the way? Yeah. All right. Now, so folks, notice that 7/2. We've already seen that 7/2 works, right? We've already seen that 7/2 work. But what happens if you put 4 in here? Okay. What happens if you put 4 in here? Now this says you can't put 4 in, right? This says you can't put 4 in. So let's see what happens if you did put in 4. If you put 4 here, you get the floor of 5, which is 4 plus 1 is 5, which is 5. Okay. And then if you put 4 right here, you get 10, right? 2 times 4 is 8 plus 2 is 10. The floor of a natural number is a natural number. So you get 15. So isn't that wild? See, it shoots all the way up to 15. which suggests really that if this were equal to 14, there would be no solution. That's another problem. But anyway, but anything less than 4 would work. Okay, anything less than 4. I'm trying to think of a nice number, and you guys can verify that if you want. What's a nice number that would go into there that's less than 4? 3.9. Okay, let's try 3.9 here. 3.9 is definitely a member of this set, right? 3.9 is definitely a member of this set. So if you put 3.9 in here, you get the floor of 4.9, right? Get the floor of 4.9. Let me put the little decimal there. And then what do we have right here, folks? 3.9, 7.8, 9.8. Y'all verify my arithmetic, make sure I'm not dogging the arithmetic there. But notice here, this is 4. Even though, the floor, it brings it down no matter what it does. It round it up, plus 9 equals 13. And hopefully this makes you trust the solution process a little bit more. Okay, so y'all, I hope you enjoyed that. Let me know what you think about the process. And also, I think this is kind of a big step right here at the very beginning. Just undress this thing in order to denude it, take away the floor notation, and you're still going to get an expression that's kind of near where the floor solution will be. 10/3 isn't that far away from 7/2, right? They're both bigger than 3. So again, hope you guys enjoyed, and leave any comments if you want.